Yellowstone National Park could be sitting on a time bomb. There is a supervolcano underneath the national treasure.
Yellowstone National Park, a natural wonder, is hiding a seismic secret that's now coming to the surface. Hundreds of earthquakes have struck, and scientists are on high alert. Is this the prelude to the cataclysmic eruption predicted by experts? Or is there something more mysterious at work beneath the geysers and hot springs? Join us as we delve into the recent tremors and discover what they mean for Yellowstone and perhaps the world. Something remarkable is happening, and you won't want to miss what scientists have discovered. Before we look at the recent seismic activity, we need to understand the context of Yellowstone National Park. Established on the 1st of March, 1872, by President Ulysses S. Grant, Yellowstone is not only the first national park in the United States, it's also the first of its kind in the world. Spread over 2.2 million acres in Wyoming, Montana, and Idaho, it's a vast expanse of wilderness, geysers, hot springs, and wildlife, including grizzly bears, wolves, and herds of bison and elk. But beneath this serene landscape lies a fact that many of us sometimes forget. Yellowstone is not just a park, it's a giant volcanic caldera, one of the largest active volcanic systems in the world. This caldera is part of the much larger Yellowstone Volcano Observatory, which includes geysers such as Old Faithful and Grand Prismatic Spring. As a supervolcano, its eruptions have the potential to be thousands of times more powerful than a typical volcanic eruption. The caldera itself is a massive crater, formed by the last of 3 super eruptions in the last 2.1 million years. The first of these eruptions occurred 2.1 million years ago, creating the Huckleberry Ridge Tuff and leaving a caldera more than 60 miles across. The second, 1.3 million years ago, created the Island Park Caldera and the Mesa Falls Tuff. The last major eruption occurred about 640,000 years ago, creating the Lava Creek Tuff and forming the Yellowstone Caldera as we know it today. This eruption was so powerful that it ejected over 240 cubic miles of rock, ash, and volcanic gases into the atmosphere, causing a global temperature drop and affecting ecosystems worldwide. Imagine a force so great that it could cover an entire continent in ash, disrupting the global climate and causing widespread destruction. Ashfall from such an eruption could bury cities and farmland, with catastrophic consequences for agriculture and infrastructure. The release of sulfur aerosols could cause a volcanic winter, cooling the planet and affecting weather patterns for years. But what if I told you the story doesn't end here? Stay with us to the end to discover the potentially catastrophic consequences of a Yellowstone eruption, a scenario that could change the course of human history. Recent studies have revealed something astonishing. There's not one, but 2 magma chambers beneath this giant volcano. The first, discovered in the 1980s, lies about 10 kilometers below the surface and contains about 10,000 cubic kilometers of molten material. But deeper still, between 20 and 50 kilometers below the surface, lies a second magma chamber that is 4.5 times larger. This deeper chamber was discovered by seismic imaging, and it's a groundbreaking revelation. Together, these chambers hold enough molten rock to fill the Grand Canyon nearly 14 times over. This discovery doesn't increase the likelihood of an eruption, but it does mean that the shallow chamber can be replenished over and over again, providing a continuous source of energy for the park's geothermal features. What does this mean for the park, and why is it important? Well, a shocking geological drama is unfolding at the heart of America's first national park. Yellowstone recently played host to a seismic spectacle that has captivated scientists and spectators alike. In the space of just 12 hours, the northern part of Yellowstone Lake experienced a series of tremors that caught the attention of experts and the public alike. The sequence began on 28 March with a seemingly insignificant 0.7 magnitude quake, but this was just the beginning of a remarkable seismic swarm. Within half a day, at least 60 earthquakes were recorded, ranging in magnitude from 0.1 to 3.7. 2 of these quakes were above magnitude 3.0, with the largest being a magnitude 3.7 at 8:24 a.m. MDT. This seismic activity was closely monitored by the University of Utah seismograph stations and the Yellowstone Volcano Observatory. Other smaller earthquakes in the region are still being investigated. While earthquakes in Yellowstone are not uncommon, accounting for about 50% of the total seismicity in the Intermountain West region. This particular sequence has reignited discussions and fears about the big one that could strike within the park. The area is one of the most seismically active regions in the United States, with between 1 and 3,000 earthquakes a year. Most are small and go unnoticed, but the recent swarm has raised eyebrows. The mere mention of a possible eruption in Yellowstone National Park is enough to send shivers down the spine of anyone familiar with the geological power of the region. For starters, it would be an event of unprecedented magnitude. The immediate area around the park would be devastated. Lava flows, pyroclastic surges, and ash falls would obliterate everything in their path. The picturesque landscapes, rich biodiversity, and iconic geysers would be consumed by the fury of the eruption. The human toll would also be devastating. Millions of tourists visit the park and surrounding areas every year. Towns and communities nearby would be at great risk, and evacuation efforts would be a monumental challenge. According to one model, the fallout from a Yellowstone super eruption could affect 3/4 of the U.S. and kill 90% of people within 1,000 kilometers of the blast. One of the most alarming aspects of a Yellowstone eruption would be the widespread ash fall. A major eruption could eject thousands of cubic kilometers of ash into the atmosphere, blanketing large areas of North America. According to one map, areas as far away as Missouri and Texas could receive more than 10 centimeters of ash, while areas closer to Yellowstone could be buried under several meters of ash. In addition, the massive amount of volcanic gases and aerosols released into the atmosphere would have a profound effect on the global climate. Sulfur dioxide and other gases could form a veil of aerosols in the stratosphere, reflecting sunlight and causing significant cooling of the Earth's surface. One study suggests that a Yellowstone super eruption could reduce global temperatures by up to 12 degrees Celsius for several years. This volcanic winter could affect weather patterns, reducing agricultural yields and leading to food shortages in various parts of the world. In the face of a potential eruption, the lessons learned from past volcanic events must guide our approach to risk management and mitigation. But the question is the supervolcano showing signs of awakening? Or are these tremors merely the Earth's way of reminding us of its ever-present power and unpredictability? To understand, we need to delve into the geological complexity of Yellowstone. The park sits atop a hotspot, a plume of molten rock rising from the Earth's mantle. This hotspot fuels the park's geothermal features and is responsible for volcanic activity in the region. It's also one of the few hotspots under continental crust, as opposed to oceanic crust. The recent swarm of earthquakes that occurred near the eastern rim of the Yellowstone caldera, close to the area of the last major eruption, has brought this geological wonder back into the spotlight, with many wondering if this is the prelude to a more significant event. Seismologists and geologists are busy analyzing the data, looking for patterns and clues that could indicate a change in the behavior of the volcanic system. The University of Utah's seismograph stations and the Yellowstone Volcano Observatory have reassured the public that the recent seismicity does not indicate an imminent eruption. The earthquakes are likely related to the movement of fluids and gases beneath the surface, a natural process in such a geologically active area. The park's geothermal features, such as geysers and hot springs, are not just tourist attractions, but indicators of the intense geological activity beneath the surface. Hydrothermal explosions are one manifestation of this activity. These explosions occur when superheated water trapped beneath the Earth's surface rapidly turns to steam, causing a violent eruption. At Yellowstone, small hydrothermal explosions, similar to unexpectedly large or uncharacteristic geyser events, occur almost every year and can pose a danger to anyone in the vicinity. For example, a hydrothermal explosion occurred at Pork Chop Geyser in the Norris Geyser Basin in 1989, and remnants of the eruption can still be seen as rock debris around the surrounding central fountain. The last major hydrothermal explosion created a crater within the park just 3,000 years ago. Landslides are another geological hazard in the region. The unstable terrain, combined with the effects of weathering and seismic activity, can lead to sudden and catastrophic landslides, blocking roads and trails, isolating parts of the park and posing a risk to hikers and motorists. This geological activity can also be exacerbated by tremors and earthquakes, which can alter geysers and hot springs and cause landslides. As we delve deeper into the mysteries of Yellowstone, we can't help but recall one of the most significant seismic events in the park's history, the Hebgen Lake earthquake. Could history be repeating itself? With a magnitude of 7.5, the Hebgen Lake earthquake remains the largest earthquake to hit the area in recorded history. The quake caused massive landslides, one of which dammed the Madison River and created Quake Lake. The landslide traveled at an estimated speed of 100 miles per hour and contained approximately 80 million tons of rock, soil, and debris. The landslide swept down the Madison River Canyon, burying a campground and killing 28 people. Roads, bridges, and buildings were destroyed or severely damaged, not only in the immediate vicinity of the earthquake, but also further away. Damage extended to infrastructure within Yellowstone National Park, affecting visitor access and park operations for some time. The earthquake also had a profound effect on Yellowstone's geothermal features. Geysers that had been dormant for decades suddenly erupted, and the patterns and behavior of others changed dramatically. For example, the eruption intervals of the famous Old Faithful geyser were altered, and new hot springs and fumaroles appeared in the park. The event led to a reassessment of the seismic risks in the Yellowstone region and prompted significant changes in monitoring and preparedness. The U.S. Geological Survey and other agencies increased their monitoring efforts, and building codes and emergency response plans were updated to reflect lessons learned. As scientists continue to study the wonders of Yellowstone, the world watches with bated breath, wondering what secrets are yet to be revealed. One clue might be none other than Yellowstone's wildlife. From dense forests to open meadows, from steaming geysers to icy rivers, the park's landscapes provide a haven for a wide variety of plant and animal species. But recently, something strange has been happening. Visitors are reporting unusual encounters with wildlife, particularly bison. 2 weeks ago, a woman was gored by a bison despite repeated warnings in close encounters. Another tragic incident occurred just last week when a woman was found dead on the Buttermilk Trail, 8 miles from West Yellowstone. Investigators found grizzly bear tracks at the scene, indicating a fatal bear encounter. The area has since been closed until 25th August for both human and bear safety, and the investigation is ongoing. The jury is still out on whether there is a link between the animal's behavior and the recent seismic activity, but some experts believe that the animals may be sensing something that humans can't. After all, these animals have lived in harmony with the land for thousands of years. The idea that animals can detect seismic activity before humans is not new. There are documented cases of animals showing unusual behavior before earthquakes, such as dogs barking excessively or cats hiding. In Yellowstone, the connection may be even more profound. The park's geothermal features and seismic activity are part of the natural landscape, and wildlife has adapted to these conditions over millennia. The bison, in particular, have a deep connection to the land. They use the park's geothermal areas in winter to take advantage of the heat, and their migratory patterns are influenced by the geological features of the region. Could the recent changes in behavior be a response to shifts in the underground magma chambers? Are the animals responding to vibrations or chemical changes in the environment that are beyond human perception? These are the questions that scientists are now exploring, looking for correlations between animal behavior and seismic data. The behavior of animals, the flow of rivers, the eruption of geysers, and the rumble of earthquakes are all connected in ways we are only beginning to understand. The threat of an earthquake or volcanic eruption in this geologically active region is a serious concern, and officials are working hard to understand, monitor, and mitigate the potential risks. The new Yellowstone Volcano and Earthquake Monitoring Plan, published by the Yellowstone Volcano Observatory, YVO, and other partners, aims to improve monitoring and hazard assessment in the region. The plan includes detailed descriptions of existing and planned monitoring systems, focusing on 2 categories: backbone monitoring and hydrothermal monitoring. Backbone monitoring refers to the existing region-wide monitoring network that has been established to monitor seismic activity, ground deformation, and other geological phenomena in the Yellowstone Plateau region. This network consists of seismometers, GPS stations, and other instruments strategically placed throughout the park to provide real-time data on geological activity beneath the surface. The plan is to expand this system over the next decade. Hydrothermal monitoring, a new part of the plan, will track activity associated with Yellowstone's thermal and geyser basins. By measuring temperature, pressure, water chemistry, and other parameters in the thermal and geyser basins, it will provide valuable insights into the behavior of the hydrothermal system and help detect any unusual changes that may signal an impending geological event. The University of Wyoming, along with other scientific agencies such as the U.S. Geological Survey and the National Park Service, is actively involved in this monitoring effort, reflecting the importance of understanding and mitigating geologic hazards in the Yellowstone Plateau region. Data from these monitoring systems will not only help scientists predict potential eruptions or earthquakes, but will also improve public safety and preparedness. While recent seismic activity in Yellowstone has reignited fears of a possible supervolcanic eruption, it's important to remember that the likelihood of such an event occurring in the near future remains extremely low. According to experts, the chances of a supervolcanic eruption occurring in our lifetime are less than 1 in 730,000. However, ongoing monitoring is critical to understanding the dynamic processes beneath the park and providing early warning of any significant changes. The Yellowstone Volcano Observatory and other research institutions remain committed to providing accurate and timely information to the public to ensure that people are aware of the risks without causing unwarranted panic. Despite all the geological activity, Yellowstone remains a natural wonder, attracting millions of visitors each year who come to see its breathtaking scenery, geysers, and wildlife.